All right, here we go. Welcome to Unit 9. Unit 9 is all about finding area of two-dimensional figures. And we're not talking middle school area. We're not talking elementary school area, which you've been doing that since second grade probably. We're talking about applying trigonometric skills, Pythagorean theorem, special triangles, 30, 60, 90s, 45, 45, 90s, to find area, something much more realistic, much more practical, an application of things you've learned throughout this year. So just to show you quick examples that are not on your paper, you know how to find the area of a rectangle. That's just base times height. But there might be some practical application where you don't know the base and the height. You know the diagonal across the rectangle, and you know the angle. That's just screaming, do some trig to find this opposite side, knowing the hypotenuse. So maybe you do some sort of sine ratio to find the height. And then of course you need to find the base, so maybe to find the adjacent side down here, use a cosine ratio. And within finding an area problem, you might have to do two trig problems to get a base and a height, multiply those, and get an area. That's what we're talking about. Similar type of example, maybe instead of that being 40 degrees, maybe that's a 30-degree angle, which immediately gives you a chance to use special triangles, 30, 60, 90s, your 1 to rad 3 to 2 ratio. So if this hypotenuse is 20, this little short leg would be 10. And of course the base would be the rad 3 side because it's across from the 60. And now you can do 10 rad 3 times 10, which would give you 100 rad 3 to find the entire area on there. That's what we're talking about, though. We are not talking about middle school or elementary school area. We're talking about big kid stuff here, applying things you already know about. So quick little introduction here. And today is sort of a focus on parallelograms and triangles. And just to refresh your memory, a rectangle is a type of parallelogram, so that falls in that category. On your paper, a quick little definition for perimeter and area. If you think back, you should know what perimeter is. You could probably fill in all those blanks. Usually in class, I give people a minute to do that. And of course, perimeter is the distance or the length around the outside of an object. You can find it by adding up all the sides, but it's a linear distance. It's adding these four side lengths together, or measuring this side, this side, this side, this side, and adding those together. It's a length or a distance, as opposed to area, which is the stuff inside, the space or the square units within a figure. So for example, this rectangle here, the area is those squares. There's a reason it's square units. It's literally a calculation of how many squares fit inside that figure. So the area of that thing would be 6. The perimeter would be adding up 2 plus 2 plus 3 plus 3, which would give you a perimeter of 10. So you're going to be, even the title of this unit is area, you're still going to be finding perimeter throughout the unit in different applications. Important little mention on here. We're talking about parallelograms or triangles for that matter. You can call any side the base. And I'm going to use little b for the base. Like I did in this triangle. I intentionally have this triangle oriented sort of, there's no real bottom. Anyone could be the base. The height is the important one. I've started to use this word altitude a little bit in the last trig unit. The height has to be drawn this way so that it's perpendicular with the base. That is the key. I could have made the height this way if I called this one the base. If I called the top one here the base, I could have made the height going that direction there. Anyone can be the height as long as it's perpendicular with the base. That's true for parallelograms as well. A parallelogram, this could be the base, or technically that could be the base, as long as I draw and measure my height perpendicular to it. Which, as soon as I create the right triangles, then you have Pythagorean theorem, you have trig, you have special triangles maybe going on at this time. So, again, the fancy term for height is altitude. You're going to see that word throughout this unit. Not to confuse this with just a side length. For a parallelogram that doesn't have right angles, this is just a side length. That is not the height. Certainly, the more I tilt this down, that's not going to change, but the height would change. The height is that perpendicular dimension on there. You want to make sure anytime you're finding area of triangles, parallelograms, or rectangles, you're using the actual height of the figure, not just a side length. So hopefully that makes sense. So I got a spot here to sort of jot down these three formulas here. You know the area of that figure. This is called a rectangle if it has all right angles. you know that area is just base times height. Nothing new for that one. And I'll give you an example that goes with it. On your paper, sketch this diagonal. It's 10 feet long. Sketch the base is 8 feet long. I'll come back in part 2 and kind of give you a solution to that. Find the area of that one on your own.